In this lecture, we're getting back on track, selecting multiple units using the drag select. Let's go. It's important to talk about our strategy for selecting multiple units. We can think of this like our algorithm that we're going to implement. We're going to keep track of the currently alive units in the player input. This is really important that we know what units can be selected. Then when we're drag selecting, we're going to determine which units are within that box drawn by the player. Whenever the player lets go, we're going to deselect all of the currently selected units, and then we're going to select all of the units within that box. I'm very sure there are more complex and interesting algorithms to do this more efficiently, but this works pretty well and is pretty easy to do. Take a look at our player input. Right now, we only have a private iSelectable selected unit, and we're going to want to be able to support selecting multiple units. And because that's going to be a variable size number of selected units, we're going to convert this over to a list of selected units. And we'll set the default size to be something like 12. We're setting a default capacity of this list because we're going to only allow us to select 12 units. This improves performance because we don't want to have this list get resized at runtime. This is going to introduce some compilation errors because we've renamed the variable and it's a different type now. That's okay, we're going to address those in a minute. We're also going to need to know the currently alive units. Right now, we don't have a base class for all of our units, we just have a worker. Because we're going to have many different types of units, we probably want to have not just a worker, but maybe a base class for all of our units to derive from. And let's make that maybe called an abstract unit. In our units folder, we'll right-click, new file, and call it abstractunit.cs. In that abstract unit, let's make it in our namespace, gamedevtv.rts.units, and define a public abstract class, abstract unit, that extends a mono behavior and implements the iSelectable and iMovable. Just a quick recap on abstract classes. We can't create instances of an abstract class. We have to make a subclass of the abstract class to create an instance. But what they do is allow us to group common behaviors and functionalities into one class that we can then subclass and have different variations or additional functionality on top of that. And let's go ahead and implement those two interfaces where we'll get the public void deselect, move to, and select at least the signatures automatically generated for us by VS Code. And everything we're doing in Worker right now looks like it's going to happen on every single unit that we have. So what we can do is refactor our worker class to just be a concrete implementation of abstract unit. Then all of this implementation here, we can move up one level to our abstract unit. So we can take our require component type of navmesh agent, make sure we import that type. And pretty much everything in here, I'm just going to cut and paste into our abstract unit. We can fix our compilation errors by just importing these classes, the decal projector, our unit deselected event, and our event bus. So now all of this is just exactly what we had in the worker. We're going to keep our worker class though, because we're probably going to need to do something in there later. So now our worker should have nothing in it whatsoever. All that logic should be elevated up to our abstract unit. Normally on abstract classes, you'll want to make it where you can reference some of these fields, but we usually do that on an as needed basis. So we're going to leave all this stuff private until we really start needing them in our subclasses. So now that we have a generic abstract unit, on our player input, we're probably going to want to know whenever units spawn. We're going to want to do something similar to our unit selected and deselected events. So again, I'm going to just copy paste unit selected event and call it unit spawn event. We can rename that to unit spawn event.cs, update that struct name to unit spawn event, and update our constructor. Now we're not going to want the iSelectable unit. We're going to want the abstract unit. Outside of this, everything's the same. We just want to reference to the unit that spawned. In our player input, now we're going to want to track those units that spawn. So we're going to want to have a new private field that will keep track of those. We're going to use a hash set today. We'll make a private hash set of type abstract unit. We'll call it alive units, and we'll set it to be a new hash set with a default capacity of 100. Maybe you've never heard of or used a hash set before. A hash set is a high performance set, and a set simply is a collection without duplicates. You can think of this like a list, but where the order of the items is not important. That statement is extremely important because when we add and remove items from a hash set, they may be reordered. Typically with lists or arrays, whenever we add things, we can tell where they're going to be in that collection by the index. Hash set doesn't have that capability. And for which units are alive, we don't really care at what point they were added or removed from this set. We just want them to be added and removed very quickly. That's why we're using the hash set instead of the list. So whenever a unit spawns, we're going to want it to raise a unit spawn event. We're going to want our player input to receive that event and to add that unit to the alive units. And that's actually going to be this lecture's challenge. For this challenge, I want you to make the abstract unit class raise a unit spawn event on start, handle the unit spawn event in the player input class, and add that unit to the alive units hash set. A tip, you can add and remove units to a hash set using the .add and the .remove functions respectively. This is going to be a little bit larger challenge than we normally do, so take some time, make sure you get this thing working end to end. This is going to really test your understanding of that event bus, and when you're done, I'll see you back here. All right, welcome back. I know this was a really tricky one. Let's go through it together now. We're going to start in the abstract unit. I'm actually going to move the awake up. I just like to have the lifecycle methods or the events that Unity raises towards the top. So we can make that private void start. And in here we do bus of type unit spawn event dot raise a new unit spawn event with this as the argument. So that looks very similar to what we did with the select and deselect. We're just using that new unit spawn event. Since this is an abstract unit and it's iSelectable, we can use this on all of these event types. Over in the player input on awake, where we're assigning these other handlers, we're going to do the same thing. Bus unit spawn event dot on event plus equals handle unit spawn. We can define our private void handle unit spawn event EVT. And we want to do live units.add evt.unit. That's all we needed to do. Producer of the event is the abstract unit. It's going to produce that event on start. Our player input is the consumer. It's going to receive those events. And whenever that happens, we're going to add units to our live units. Remember that very importantly, we need to be hygienic, and unsubscribe from these events on destroy. So we didn't do that with our unit deselected or handle unit spawn yet. Let's make sure that we unsubscribe from both of those on destroy. Now our player input is going to know about all of these alive units. So now let's move on to fixing our selected unit. If we scroll back up to the top here, we can rename our selected unit to selected units with an S because it's a list. There should be more than one, plural. And we can scroll down to handle unit selected and handle unit deselected, update that to say selected units instead of selected unit. Keep our handle unit selected deselected together and our handle unit spawn below those. Now, because we can select multiple units, we don't want to just override our selected units. So whenever we select a unit, we just want to add that unit to our list. And whenever we deselect a unit, we just want to remove them from that list. So we can do selected units.add evt.unit to add them and selected units.remove evt.unit to remove them on handle unit selected and handle unit deselected respectively. So you can now see all of these handlers are only one line of code. And really we're just maintaining the state of a list. And remember a second ago, we said if we're only going to have one line of code, we can shorten these so they don't take up so much space to an expression bodied function. So on handle unit selected, we can remove those curly brackets, put a fat arrow to selected units.add evt.unit, and put a semicolon at the end. We've collapsed those 4 lines of code into one. So let's repeat that process for all of these event handlers because they're all one line right now. That saves us a lot of space in our classes. Now let's come down to our drag select. What we're going to want to do is, as we're resizing this selection box, we want to find all of the units that fall within that box. But we don't want to apply any changes to our selection before we've released our pointer. So first things first, we want to find out the size of this selection box. So it'd be really convenient if, whenever we resize a selection box, if it told us what the new size was. So we can say bounds selection box bounds equals the return value of resize selection box. Down here where we have private void resize selection box, this isn't a private void anymore. We now want it to be a private bounds resize selection box. And at the very end of this, we can return a new bounds where the center point is our anchored position and the size is that size delta. So as having this pivot here makes this return value very simple. All we need to do now is go over all the alive units and see which units are within these bounds. So we can do a for each loop for each abstract unit in the alive units. In that for each loop, we can do vector2 unit position equals camera.world2screen_point. This transforms that world location of the unit to a screen space location. So we just need to provide to it the world space position. That's the unit.transform.position. And now we know where on the screen is this unit. So we can simply check if the selection bounds box contains this unit position. Then we want to select this unit whenever the mouse is released. But now we have a little bit of a problem because we want to wait until the player releases the mouse before we actually do the selection and deselection. Do you have an idea of how we can do that? What we're going to do is back up at the top, make a private hash set of abstract units. We'll call it added units and set it to be a new hash set, maybe with a default size of 24. I'm picking relatively arbitrary sizes for these that seem like they might be a good number. They're not super important. So with the added units, back down in handle drag select, whenever we start dragging, we want to clear this because we don't want any residuals left over from the previous time. If this unit, this alive unit, is within our selection box bounds, then we want to say, yeah, we want to add this unit. So we can say add units.add this unit. And down here at the bottom, I think you know what we want to do, but it's a little bit more tricky than you might initially think. We actually want to do this in the inverse order. We want to deselect all of the currently selected units, and then we want to select the units in our added units. But if we just do something simple like for each iSelectable, selectable, and selected units, selectable.deselect, well, that's not going to work because our selectable deselect raises an event that modifies this list. So we'll get an error at runtime because we've mutated this list while iterating over it. So to prevent ourselves from running into this problem, we'll scroll down a little bit and make a private void deselect all units, where we're going to do basically this for each loop, but we can't do a for each on the currently selected units because that can change. So we can take a snapshot of our currently selected units with iSelectable array currently selected units equals selected units.toArray. Now currently selected units is not going to be mutated whenever we call deselect. So we can do for each iSelectable, selectable in currently selected units, not just selected units, selectable.deselect. Back up in our handle drag select in that last else if, we can now say deselect all units. After we've deselected all of the units, we want to iterate over all the added units and select them. We can do that simply with for each abstract unit in added units, unit.select. And again, remember select is going to trigger an event that gets them added into our selected units. We're almost there. If we come down a little bit, our handle right click still has some compile errors because we're checking this selected unit is not movable and this is a list now. So we can use our guardian pattern just to check if selected units.count is 0. We can do an early return, deleting that last part about the selected unit is not iMovable because we're going to check that a little bit farther down. And then in our if the right mouse button was released and we hit something with a raycast if statement, we can go over each of the current selected units and check if they are movable and then try to move them. So we can do for each iSelectable, selectable in selected units. In there, if the selectable is iMovable, movable, that was our if statement at the very beginning earlier, movable.move to that hit point. So we're doing the exact same thing just for every selected unit. And on the home stretch, handle left click. There's actually a super tricky thing for us to worry about because if we drag select, we want to retain whatever drag selection happened. But if we just left click, we want to select that one unit. And if we haven't moved the mouse really very much, this line here, the unit position on the screen may not be within that little box. And since I think we're running out of time for this lecture, my recommendation is for right now, we only have the drag select. But don't worry, we're going to come back. We're going to make it where we can left click, we can drag select and do even more than that in a future lecture. So you can choose to comment this out or completely remove it. We hop over to Unity and click play. Now if we just click, it's not working, but if we drag a little box, this unit gets selected. We can right click to move them. We can drag select to get both of them and right click to issue a command to both of the units. And we'll see there's a little glitch with our selection box. I think whenever we set selectionbox.gameObject active to be true, it still has until the next frame its old size. So we can do selection box.size delta equals vector to 0 whenever we first press down that mouse button, so we won't see it from the previous size. One more time over in Unity, if we drag select, we get both of them. Right click to move, they both move. And as we drag select, we don't get that weird artifact anymore. We can select just one unit, move them, select the other one, move them somewhere else, and get them both. So that's working pretty well. That's all we have time for in this lecture. I hope you learned a lot and really solidified your understanding of that event bus. When you're ready, I'll see you up on the next one.